Back in 2003, this was the clearest view we had ever had of Pluto from a telescope. This is what we can see now, thanks to NASA's New Horizons space probe mission. These stunning views are also thanks to data collected by New Horizons. New Horizons' primary mission was to study Pluto and its moons, including Charon, seen here. Pluto and Charon are located in a region of our solar system called the Kuiper Belt, a huge region of planetary leftovers. These rocky objects never got to become planets.
We tend to describe it as a donut. The spatial distribution is a donut with the sun at the center, nothing for a while, and then a ring of material. Okay? And this object is in the main part of that donut and is thought to have been there ever since the solar system formed.
That's Dr. Brett Gladman, an astronomer at the University of British Columbia. Because they're so far away, the only way to get a good look at these objects is through space probes like New Horizons.
Well, we can't use a telescope on Earth to look into the Kuiper Belt and see a 1 kilometer projectile. They have to be 100 times larger than that.
After it passed Pluto, the New Horizons team adjusted the probe's course. 4 years later, it flew by a tiny planetary object called MU-69, located much deeper into the Kuiper Belt. New Horizons' updated mission was to get a good look at the craters on MU-69's surface.
So there's a unique window into understanding what's the number of Kuiper Belt objects all the way down to sub 1 kilometer by looking at the impact craters that they have created on a planetary surface.
In other words, by studying the number and size of craters on MU-69, Dr. Gladman and his fellow astronomers can precisely determine the numbers, sizes, and distribution of objects in the Kuiper Belt, even objects that are much too small to see with even our most powerful telescopes.
So this is the very first time people say, okay, now we have all of these models of how you condense material out of the cloud of gas and dust that surrounded the early sun and made the solid objects that you then put together into planets. Well, we now know what you have to get to because we've got the size distribution measured by putting all of this information between the spacecraft data and the telescope data together down to 100 meters. We know what the early solar system made out there.